So today we will be multiplying and dividing rational expressions. Now, what I want you guys to do in the next few minutes is I need you guys to find an equivalent rational expression that is reduced. In other words, I need you to look at these problems in the warm-up, parts A and B, and you're going to simplify them. What does that look like? We talked about this last week. To simplify, you need to find the greatest common factor and cancel the greatest common factor out. So you want to make sure that whatever you have on top and on bottom is the same in order for it to be simplified. If it is not exactly the same, you cannot simplify it. So don't start just like crossing x's out just because you see x's up there and below that. All right, so take a few minutes. Not only are you going to simplify, but also, let me highlight this, you are going to determine whether there are any excluded values. If you're not sure what excluded values are, look at last week's notes. Go ahead and begin. All right, so for the warm-up, remember, you were asked to do two things. Number one, you were asked to reduce the expression that is given to you. And number two, you were asked to find the excluded values. Keep in mind, there will always be at least one excluded value. All right, so don't ever put no excluded values, because that's not true. All right, looking at A. So for problem A, we have 2x plus 12 and then x plus 6 squared. For 2x plus 12, let's find the common factor. Now, do both terms share an x? For the top. No, only 2x has an x, 12 does not have an x. So we can't take a variable out. We can only take a number out. What number is a factor for 2x and 12? 2. So we're going to take out a 2, and that'll leave us with what on the inside? X plus 6. Underneath, we have x plus 6 squared. Now, if it's squared, then it's telling me that we have how many groups of x plus 6? 2 groups of x plus 6. So we can go ahead and expand this. X plus 6 times x plus 6. Now, typically, this is where we would find the excluded values. Now, the way that we find the excluded values is you look at your denominator, and what an excluded value is a value of x that makes your denominator equal to 0. So we take a factor or both factors from our denominator and we set those equal to 0 to solve for x. In this case, because we have x plus 6 twice, we can just do it once. X plus 6 equals 0, which means that if x were to equal negative 6, then our statement underneath, meaning our denominator, would become a 0, giving us an undefined function. This is what we don't want. So we get x equals negative 6 as our excluded value. Let's go ahead and label that. All right. Now that we have the excluded value out of the way, we can go ahead and give our simplest version of the expression given to us, which in this case is when we will start to cancel things out. In order to cancel things out, number one, you must be multiplying the terms together. You can never cancel anything if you're adding or subtracting. Number two, you can only cancel things that are exactly the same. If they look similar but are not the same, then you cannot cancel them out. They have to be exactly the same. So we have an x plus 6 here that we can get rid of, and an x plus 6 down here that we can get rid of, giving us a final answer of 2 over x plus 6. All right. Give me a thumbs up if that is what you got as your answer for number or for letter A. Very good. So most of you guys. Okay. Moving on to B, we have a little bit more of a challenging question, but you have to take it in parts. Do the top first, do the bottom next. For the top, we have 6x squared minus 30x. Do both terms share a variable? Yes. So not only are we taking a number out, but we are also taking a variable out. For 6 and for 30, we can take a 6 out. And then to determine how many x's we can take out, you determine which is the lowest amount of x's in that sequence. And we have an x squared and an x to the first. So we're going to take just x to the first out. So we take 6 and x out, and we're left with x minus 5. 6x times x minus 5. For the bottom, that is going to be a difference of squares. And you guys at this point need to start getting better at like just looking at it and knowing, hey, that's a difference of squares, just right off the bat. It's going to be more efficient if you're able to see the patterns for that. So for x squared minus 25, since that is a difference of squares, how can I rewrite x squared minus 25 as a difference of squares? What would I do? What are the factors going to look like? Josiah? X plus 5 and x minus 5. Now, before you move on to canceling things out, don't forget to find your excluded values. So set your denominators equal to 0 and solve for x. We're saying that x, if x equals negative 5, that's an excluded value, and if x equals positive 5, that is another excluded value. So here we have our EVs, excluded values, and once again, these are values of x that result in a denominator of 0, which is what we don't want because we are not able to divide by 0. That yields an undefined statement. All right. Anyway, so now we can cancel things out. Is there a 6x underneath that I can cancel out? No, we only have a 6x on top. Is there an x minus 5 underneath that I can cancel out? Yes, I can take this x minus 5 and this x minus 5, and my final answer will look like this: 6x over x plus 5. That is my simplest form. Okay. Everything that we do today will stem from this, meaning you will be factoring, you will be canceling at some point in the work today. We're just adding some extra steps beforehand because we're going to be multiplying and dividing these like big rational expressions. We're going to first look at some numbers and how we would do some numbers, and then we'll kind of extend that idea to some variables and some more challenging types of questions. Are there any comments, concerns, anything I can clarify for you guys here in the warm-up before we move on to the next portion? All right. Very good. So I know the section here says with your team, but I want to do it with you guys just to make sure that we are able to kind of do the process how I want you guys to do it. So let's do just very basic fractional multiplication and see what we get. So in part A, we have 2/3 times 9 over 14. 2/3 times 9 over 14. How do I multiply 2/3 times 9 over 14? Let me ask you this first. Do I need a common denominator to be able to multiply these fractions together? Meaning, do I need to have the same thing underneath for both fractions? What do you guys think? No. Okay, so if I don't need a common denominator, then do I cross multiply? Is it safe to say that I multiply 9 and 3 and then 14 and 2? Is that going to give me the correct answer? What do we think? Straight across the top and straight across the bottom. Very good. So we want to do this. We're going to go across and across. So if we go across, then I have 2 times 9, which is what? 18. And I have 3 times 14, or 14 times 3, which gives you 42. Now, some of us are good with multiplying in our heads, some of us aren't. For a lot of you guys, maybe 14 times 3 is kind of challenging. You have to like work it out, or you have to get a calculator. Now, is 18 over 42 a simplified answer? No, the fraction 18 over 42 can be reduced. Do you guys know what goes into 18 that also goes into 42? Now, I want you guys to think greatest common factor. I know that both 18 and 42 are divisible by 2, but I don't want to divide by 2, so I want to be more efficient. What is a bigger number than 2 that goes into 18 and 42? 6. How many of you guys were able to come up with 6? A few of you. Very good. But let's be honest, not everyone, right? So it can be hard. Not everyone knows their times tables. But anyway, so if we divide top and bottom by 6, then we get a final solution of 3 over 7. And while this may, or this, well, not may, this is a correct solution. This is a correct answer. it's not a wrong approach, but there are more efficient approaches. All right. And so what I want to show you next is, instead of waiting until you simplify at the end, I want to show you guys how to simplify in the beginning to save yourself all this trouble of having to reduce things at the end when the numbers are large and when it's more challenging to see the factors. So let me show you the next thing then. Same problem, 2/3 times 9 over 14. I know this is going to seem dumb, but I'm going to separate the terms to help you visualize what can be reduced. Eventually, when you start making patterns on your own, you can skip this step. But for now, just so everyone can see what's happening behind the scenes, I'm going to show you the long way. All right, so I have 2 over 3. Can 2 over 3 be reduced in any way, shape, or form? Or can I separate it or do anything with it? No. If I were to take 2 and separate it, I would get 1 times 2 and 3 times 1. And there's nothing I can do with those. So 2 over 3 is going to stay the way it is. But what about 9? Can I separate 9? Can I split 9 into its factors? What 2 numbers multiply to 9? 3 and 3. And then what 2 numbers multiply to 14? 7 and 2. All right. Now, just like how I showed you in the warm-up, when you have the same thing on top and on bottom, as long as you meet 2 conditions, you can start canceling things out. And now, what are those 2 conditions? I said it earlier. Condition number 1, you must be multiplying the terms together. In this expression, are we multiplying the terms together? Yes, so condition 1 is met. Condition 2, you must have the same exact thing in the top and the bottom. Let's go ahead and figure out if we meet that second condition. Do I have any 2's in the top and the bottom that I can cancel out? Yes, I have a 2 here and a 2 here that I can cancel out. So cross them out. Do I have any 3's that I can cancel out? Yes, I have a 3 here and a 3 down here. So what are you left with? 3 over 7. Same answer, different approach. You might think, well, this is a longer way of doing it. If you're stuck in your ways, do it your way. That's fine. But this is a more efficient way because you don't have to figure out what goes into larger numbers. And right now it's just numbers. But when we do variables, you're going to be actually out here factoring like trinomials or, difference of squares or this or that, and just extra steps that you do not have to do. Okay? So we're going to stick with that second way that I just showed you for basically the rest of the lesson today. All right, so that is multiplying fractions. Now let's talk about dividing fractions, because dividing fractions is a whole different approach. What must we do when we divide fractions? There's a set of steps that we have to do before we even get to the problem. Does anyone remember from like 7th grade? Yes. Okay, so close. You only need a common denominator though when adding and subtracting. So no, we don't need a common denominator for this one. It's a different approach. All right. Any other ideas before I give it to you? Go ahead. You flip one fraction, but you don't flip all the fractions. What is that? Keep. You had it. Keep what? Keep, change, flip. We must keep, change, flip to be able to solve this. So what does that mean? Keep, change, flip. This is what you do. You keep the first fraction how it is. You change the division to a multiplication sign, and then you flip the second fraction. That way the problem becomes 3 over 5 times 25 over 12. So 3 over 5 times 25 over 12. Okay? Now let's take the approach that I showed you in the last problem. Can I split 3 up? No, I would get 3 and 1. Can I split 5 up? No, I would get 5 and 1. But can I split 25 up? Yes. 2 numbers that multiply to 5 are what? 5 and 5. Two numbers that multiply to 12 are 6 and 2, but if I have a 6 and a 2, I can't cancel a 6 and a 2 out with a 3. So let's do 3 and 4 instead. Now we can cancel things out. I have a 3 on top. Do I have any 3s below that I can cancel out with? I have a 3 on top. Let me say that again. I have a 3 on top. Do I have any 3s below that I can cancel out with? Yes. So let's do that. Let's cancel that out. This one with this one. All right. I have a 5 on top. Any 5s on the bottom that I can reduce or cancel with? Yes. So what are you left with? 5 over 4. Okay. All right. Are you ready to start applying this with some variables? Let's do it. All right, so you want to use your understanding of multiplying and dividing fractions to extend it to work like this right here. So 4x plus 3 over x minus 5 times x minus 5 over x plus 3. This is what I like to do before anything else, and I think you're going to find this quite useful for you as well, is you want to rewrite this, but with parentheses, just so that you're reminding yourself that we are multiplying these terms, or that, you know, they're groups, basically. So we have 4x plus 3 over x plus 5 in parentheses times x. I'm sorry, this should be minus 5. X minus 5 over x plus 3. Okay. Let's remind ourselves of the two conditions that need to be met to be canceling things out. Number one, we need to be doing what operation? Multiplication. Are we multiplying? Yes. Number two, terms need to be exactly the same. If they are not, we cannot cancel them out. And this is what I mean. Some people might be tempted to do this. Okay, let's cancel the x plus 3 and the x plus 3. Oh, we're left with a 4. Can I do that? No. Why not? The x value is not the same. A 4x plus 3 on top cannot cancel with an x plus 2 on the bottom unless the bottom group was also a 4x plus 3. In this case, it is not, so we cannot cancel that out. However, what we can cancel out is the x minus 5 with the x minus 5. So that's what we're going to do. We're going to cancel this one with this one. So what are we left with? We are left with 4x plus 3 over x plus 3. And like I said, you cannot start doing this. Okay, 3 with a 3, x with an x. You cannot do that because the conditions are no longer being met. We are not multiplying the terms together. We're adding them. And you can't cancel things out when you add or subtract terms. Okay? Now, let's not forget, part of the instructions also ask us to state any excluded values. So let's go ahead and do that. You want to state the excluded values for the denominator, which would be x minus 5 and x plus 3. So set those equal to 0. The excluded values would be what? What's one of the excluded values? Go ahead. 5. And what's the second excluded value? Negative 3. Let's label those excluded values, and we're done. All right. Any questions so far on how we solved the first question? All right, I'll show you one more example, and then you guys can go ahead and try it on your own. So now we're dividing these two fractions, one from the other. What step must we do? We must keep, change, flip. Let's go ahead and take care of that first. Keep, change, flip becomes x plus 2 over 9x minus 1 times 9x minus 1 over 2x plus 1. I'll go ahead and also put parentheses around my factors just to remind myself that these are groups. These are not individual terms. All right. It's a group of x plus 2. It's a group of 9x minus 1. It's a group of 2x plus 1. Otherwise, I might, get greedy and start canceling things out just randomly. You don't want to do that. So 2 conditions. First condition is met, right? We are multiplying. Second condition, we're going to meet right now. Do I have any x plus 2 groups that I can cancel out underneath? No. Do I have any groups of 9x minus 1 that I can cancel out with? Yes, I have this one here and this one here. And so that's going to yield a solution of x plus 2 over 2x plus 1. Simplest form. Let's not forget our excluded values. You are also including factors that you have canceled out. So 9x minus 1 and 2x plus 1. That means that x equals 1 over 9 is one excluded value, and x equals negative 1/2 is your second excluded value. What's up? 9x minus 1 because that's part of the denominator. I did cross it out, but when you find excluded values, you have to find them for any factor that was at one point in the denominator. Otherwise, you're not finding all excluded values. If you just take the denominator of this one right here, 2x plus 1, and just find that one, that is not going to include all excluded values. Okay. So typically, you want to find excluded values before you cancel things out. I just kind of got ahead of myself and did that. But yeah, so you're finding excluded values on these two. No, not yet. All right. Let's label these excluded values. All right. Anything I can clarify for you guys before I let you try this on your own? All right. So the next task then will be a team tutorial session, and I'm going to give you some instructions in just a moment.